Okay, well, how's everybody today? Good? So how was the quiz? Hard? Okay. Depends on how long she takes. We'll kind of see. We might have some time at the end. All right, so I will try and get those graded as soon as I can in the grade books. I'll be looking at that, and if you need to, we could retake that next week. But we're probably going to have to take some time on Tuesday to talk about some of those questions. Okay, probably a few of them. Okay. All right. Well, let's see how far we can get with compound interest today. We introduced it yesterday. We talked about simple interest, compound interest annually specifically, and I don't think we got further than that, did we? Did we work this example? No, we have not yet. Okay. So let's go ahead and start here. So we're looking for a formula for interest compounded annually. That means just once a year. So I, of course, is the interest that you're going to earn. C is the capital that you invest. R is the interest rate. Now here we're going to keep it in a percent because we're going to divide by 100. That's going to change it from a percentage to a decimal. And then N is going to be the number of years. Okay. Now, of course, you go ahead and subtract the initial amount if you just want the interest. If you just want the amount in that particular account after N number of years, then you don't worry about subtracting off that particular amount. Okay, well, let's see what we got here. A student invests $560 at 6% annual interest compounded annually over a period of 10 years. Calculate the total amount in his account at the end of 10 years. Okay, well, let's identify all the different variables here. And really, again, this is just a formula. You're just substituting in. As long as you got all the parts correctly, you can just plug it in and let the calculator take over from there. How much are we investing? 560. Okay, so there's my C. Okay, what's my interest rate? Okay, so that's my R right there. How long are we going to leave it in? Okay, 10 years, so that's my N, and looks like I have everything I need. So the formula here, because it says calculate the total amount, so I'm going to use this one here. Okay, the amount is equal to 560 times 1 plus. Now again, we're going to leave this as a percent. The old formula you looked at, probably Algebra 1, Algebra 2, would have you change it to a decimal, but we're going to leave that as 6 and then divide by 100. Then we're going to go ahead and raise that to the power n, which in this case is 10 years. Okay. And then it's just a matter of typing it into the calculator. Let's see here. So 560 parentheses, okay, 1 plus. And every time I have a parentheses or show me a fraction, especially with this type of formula, I hit Control Divide and it just gives me that ratio. So I can just go ahead and type in 6. Whoop, it did not take it. 6. There we go. And then 100. All right. If it'll take this, there we go. And then I want to go ahead and raise that to the power of 10. There we go. There we go. And I think I might do the rest of these from the mouse. Okay. But what should I be getting as soon as I push enter if we get the 6% once a year for 10 years? Anybody? What should I get before I push enter? Okay. So Spencer says 1002.07. Okay, so mine gave me a huge fraction. So I'm going to hit Control Enter, $1,002.87. Perfect. Okay, good. 1,287. Okay. And the one thing you're going to notice about these formulas as you go through, the power that you're raising this to, that's the total number of times over the life of the investment that interest is going to be applied to whatever's in the account. Okay, so we're doing it once a year for 10 years, so the power is just going to be 10. You'll notice we're going to take a product as we move into multiple times per year that will compound it. Okay, B, calculate the total amount this student would have in his account if he had invested the same $560 into a simple interest account at 6% a year for 10 years. So what was the formula we were looking at yesterday for that? Yeah, remember there was two of these. We either had I is equal to PRT or I is equal to CRN divided by 100. Okay, let's just go ahead and use the I is equal to PRT. Okay. All right, so I is equal to PRT. All right, so we're still going to invest the same $560. Okay, times R. Now here, do I leave it as a percent or do I change it to a decimal? Change it to a decimal, yes. So this is going to be 0.06, and then we're going to leave it for the same 10 years. Okay, so let's see here. That was 560 and 560. It is taking so long now to type in something on the calculator because it's not recognizing this, and I'm going to keep hitting it. Okay, so I'm going to go use the mouse. Okay, so I'm going to delete that. Hopefully, let me go 560 times 0.06, parentheses, 10. Okay. So I've got $336. Now, remember, what's the question saying? Calculate the total amount he's going to have in his account. Now, this is just the amount of interest. So I still need to go ahead and add that to the 560 that we initially invested. So plus 560. Okay. So I'm looking at $896. Okay. So let me go back over here. He earned $336 in interest. That's pretty interesting. Well, I think that's the trick, though. I think some people noticed that either did the eye roll or just went, just did a big old sigh. All right. Okay, what was the total when we added up? So $896. Okay. All right. You know, it's kind of curious. Does it ever get to the point where you're just like, hey, yeah, I get to go to math studies? Or you're like, yay, I get to go to math studies.
I look forward to this.
You look forward to this class? Okay, nice. So my jokes ever don't detract from the knowledge I pass on to you?
What's the knowledge you're passing on?
I'm sorry, what?
I thought that was the knowledge you're passing
The jokes are the knowledge.
The jokes are the knowledge? There you go. If you don't learn anything about math, you know about humor. Okay. Okay, so C, not that I know a lot about humor to begin with, but how much more does he earn in compound interest than in simple interest? Okay, so what do I do here? Yeah, I'm just going to subtract the two. Bless you. So $1,002.87 minus 896. Okay, and somebody help me out here. What's the difference of the two? 106.88. Okay, is that what you guys agree? Okay. All right. Anybody having trouble so far? Yes.
I understand the equations and how to solve them,
Mm-hmm.
but I'm having a hard time wrapping my brain around what exactly is interest compounded annually versus simple interest in real life.
Okay, so the trick here, and what a lot of people don't usually understand, is that things are always done on a year basis, no matter the percent that you get. So, for example, if you're going to get 6%, but you're only going to do it once a year, it's going to be whenever it's set up with the bank. But when you start to compound things annually, you don't get, say, the 6% however many times you compound it. It's divided by the number of times you're going to compound it. So let's say, for example, just to make things easy, let's say, January, February, March, April, May, June, July, August, September, October, November, December. Okay, the 12 months of the year, right? And let's say, just for argument's sake, just to make this really easy, this is not realistic in any way. Let's say that you're going to get 12% and you're going to compound it monthly. So what does that mean?
So you're gonna split up your percentage between the months.
There you go. That's exactly right. And that's why in the old formula, this is why we were doing this. And the new one here is just a modified version, for IB. But P times 1 plus R divided by N to the NT is the formula that we're accustomed to. In fact, how many people recognize this one? hopefully quite a few. But the reason we have to take the percent and divide by that is because you don't get 12% every single month. It's on an annual basis. So whatever percentage you're going to get, the number of times you compound it, when you add that together at the end of the year, that's the percentage you're given. So in this particular case, if I were going to compound it monthly 12 times a year, okay, but I'm getting 12%, how much am I actually applying to my amount every month? 1%. So I would have 1% increase in January, 1% in February, 1% in March, all the way through to December, where then on an annual basis, that would add to the 12%. Okay, does that kind of help to make it a little better? Okay. So see, the more you compound it, the higher the yield you're going to get. But what you're going to start to realize is that the more you compound it, that growth is going to slow. Okay. It is going to slow. It'll always be the highest, but it's going to slow. In fact, a lot of times, banks might use it as a marketing ploy. Like if you go ahead and invest your money with us, we'll go ahead and compound it continuously, which is not one of the formulas that they're having you look at in here. But does anybody remember, and I mentioned this briefly yesterday, right at the end, does anybody know, and I'm looking at my old Algebra 2 kiddos, anybody remember the formula for compounding continuously? PERT, that's the PERT formula, yes. Okay, that's the PERT formula, because you never get a second chance to make a first equation. See? Okay. Now, I don't even know if it's still on the market. Do they sell PERT shampoo? PERT Plus, whatever it is? Yeah, it's still on the market. They used to have a campaign that it makes your hair so nice because you never get a second chance to make a first impression. Am I that old where you guys don't remember that old advertising campaign? You kind of remember that campaign? Well, see, I kind of did it with math because you never get a second chance to make a first equation. See, it's pop culture and it's math. So there you go. Okay. Well, you know what? I say pop culture because it was from when I was a kid. So Mr. West is old. That's the moral we're going to take away from this. Okay. All right, so now let's go ahead and look at different compounding periods. Okay. So interest can be compounded more than once a year. Commonly, it can be compounded. And these are just, things you'll want to kind of commit to memory. So if it's half yearly, that's 2 times a year. It might also be written as biannually. Okay, something like that. Quarterly is going to be 4 times a year, so that means every how many months? Every 3 months, okay, because it's 4 times the year, okay. Monthly, as I just said, would be 12. You could do daily. It can be done hourly. And see, again, the more you compound it, the higher the yield, but the growth does slow, especially if you start really looking at the numbers. It is an exponential function. Okay, so K is the number of times that the interest is compounded in 1 year. Interest rates are generally given as R percentage annually. So if an investment is compounded quarterly, it earns R divided by 4% each quarter. Okay, and this is what I was talking about in the old formula where we divided by N, but we're kind of repurposing these variables. N is now our number of years, and K is the number of times that we're going to apply the percentage. Okay. So here is the compounding K times annually formula. And you'll notice there's just one change. What is it? We have that one additional K here. Okay. So we have the R divided by K that the previous notes were just talking about. And again, your power is always going to be K times N. The number of times per year you compound it times the number of years. That's the total number of times over the life of the investment that interest will be applied to your account. Okay. And then, of course, you have the one here for the interest itself by subtracting off the principal amount or the capital you originally invested. And then you also have just the normal formula, which is more likely what you're going to be using just to get the total amount in the account by the time it's done. All right. Well, let's go to a problem. Let's see what we have here. Find the interest earned over a 5-year period if $1,500 is invested in a savings account that pays 6% annual interest compounded monthly. Okay. So let's go ahead and identify all our variables here. Which variable is the 5? Okay, that's N. That's my number of years. Okay. 1,500? That's the capital. That's C, the amount that we're going to go ahead and invest. All right. What is 6%? That's the percentage. Now, in this formula, am I putting it in as the percent or the decimal? The percent. Because in the formula, you're dividing by 100. So that 100 will take care of the decimal change. All right. We're going to go ahead and compound it monthly. Now, that means 12 times a year, and that's what? K, right? Okay. Everybody okay with that? Sorry, it's Friday. I'm a little giddy. It's got a 3-day weekend, man. I'm excited. Okay. Sydney knows what I'm talking about. She's excited. You can tell this by looking at her. All right, so let's go ahead and plug everything in. So we're finding just the interest earned. Okay, so I'm going to start with the amount we're investing, $1,500, times 1 plus, so we want R divided by 100K. So we're getting 6%. Again, we're going to leave it as a percentage. Now 100K, so what would this be? 100 times 12. 1,200. And then we're going to raise it to a power of K times N. All right, so we're going to do it 12 times a year for 5 years. So how many times over the 5 years will interest be applied? 60. 60 over the lifetime. Now, this is going to be the total amount. If I want just the interest earned, then I'm going to subtract off the original 1,500. We're just going to see how much it grew. Yes, ma'am.
Wait, where's the 60 coming from?
Oh, the 60 is coming from the power right here. So the power is always K times N. So I'm going to go ahead and take the 12 times a year times the 5 years to give me the 60. All right, and then it's just a matter of typing that in and seeing how much interest we've got. Okay, so I'm going to do this over here. It's probably going to go a lot faster. Document B. 1,500 times 1 plus, okay, so control divide. We got 6 over 1,200. Okay, and I'm going to raise that to the power of 60. And then I want to subtract the original 1,500. Okay, so what should I be getting when I push enter? A ridiculously large fraction, which I'm going to hit control enter. So I'm getting $523, about 28 cents. Okay. Yes. Yes. So this isn't the total amount. So actually, at the end of 5 years, the total amount would be $2,023.28. This is just how much it's grown in the 5 years. Yeah, the interest. Okay. And remember, if you just wanted the total amount, then we wouldn't worry about the minus 1,500, minus the original. Okay. And actually, I really do think, no pun intended this time, that this stuff can really be interesting. Has anybody, because a lot of times when I've taught this, this is probably the one concept that relates directly to a lot of my students. Does anybody out there have some kind of account that maybe a grandparent or a parent set up when you were little? Might not be a bad idea. Find out the information, see what percent you're getting, how long it's been in there, and you can calculate these things. Okay. Now, what I'm going to go ahead and show you come Tuesday, there's a financial solver in your calculator that can do all of this for you. Personally, I like to use the formula, but I will show you that as well. Okay. I'm sorry? You have homework on Tuesday? Yes. Okay. The homework is over the currency conversion. How's that going? On the proportions? Okay. All right. So more than likely on Tuesday we'll talk about the quiz, we'll talk about the homework, and then we'll see how much further we can get. Okay? All right. Good.